The last example has our constraint given in a different format. Here's the other format you can have when you're given a greater than or less than relationship. And this is just saying, the constraint there is just saying cotangent is negative or cotangent is positive. Here cotangent theta is greater than 0 is just saying where is cotangent positive. So I need to look at each of these pieces and see where do I have an overlap of true statements. Here the secant is negative, and there's two quadrants that secant is negative. It's the second quadrant and the third quadrant. The second part then is the cotangent is greater than 0. Cotangent can be positive in the first and the third quadrant. So I look at these two relationships and I see quadrant 3 is the common piece between both of them. So that tells me that I'm going to draw my reference triangle in quadrant 3. Now I need to figure out what the other sides are going to be. Secant, I know, is the hypotenuse over the adjacent. So the hypotenuse will be 4, the adjacent will be 3. And I know that adjacent is going to be negative because the hypotenuse piece is always positive. I then need to find the opposite side, and this is not a 3, 4, 5 triangle because a 3, 4, 5 triangle has the hypotenuse as being 5. So I've got to use Pythagorean theorem in this case. So x squared plus y squared is equal to r squared is one way we can use Pythagorean theorem, or a squared plus b squared is c squared. Negative 3 squared plus y squared is equal to 4 squared. Y squared is equal to 16 minus 9, which is 7. So y is equal to the square root of 7. And in this case, since we're going down, it's going to be a negative square root of 7. So now that I've got all three sides of my reference triangle, I can list out my 6 trig functions. So sine of theta is opposite over hypotenuse, negative square root of 7 over 4. Cosine of theta is adjacent over the hypotenuse, negative 3/4. And tangent of theta is going to be the opposite over the adjacent, which is going to be a positive square root of 7/3. And then finally, for cosecant, secant, and cotangent, we're going to take the reciprocals. I was already given secant in the original problem, so I know that's going to be negative 4/3. If I flip negative square root of 7 over 4 and rationalize the denominator, that ends up being negative 4 square root of 7 over 7. And then if I flip the fraction for tangent and I rationalize the denominator, I'll get 3 square root of 7 over 7.